So anyway, when we brought the Mustang, it was like tires were all dry rotted to the ground, and it was a mess. It was just kind of, it was pretty rotten. And like the tires, dry rot's when the rubber, do you know what dry rot is? It's like when the rubber loses all its elasticity and it gets dry and crumbly. So they were flat to the ground, just flat. And we popped the hood and there were vines growing all through the engine. And there was moss on one of the windows because the guy who owned it was the original owner, and he drove it from, it was like Washington State or Oregon or something like that. He drove it all the way across the country, and he parked it under a carport. That's like the thing that has a roof, but it doesn't have walls. This one had one wall, but it was 3 sides open. So it had been out there forever, and it was rust. And so my dad bought it for like a measly $500, and we put it on the back of a flatbed and towed it back. And then he spent a year restoring it. And I drove it from 1993 till 2004, which is a good time.
I wasn't born yet.
Yeah, there you go. And in 2004, I was driving home from work, and I shifted into second gear, and there was this awful sound. And I knew, like, it was my transmission. It was gone, and I knew.
Transmission?
So that's what takes, that transmits the power that the engine's making and converts it into power that turns the wheels. Right. So the transmission was gone, and I knew that was it. So he towed her back to Virginia, and no, he didn't tow her back to Virginia. She stayed here. He towed her back to Virginia 3 years ago. So it's been 15 years since I've driven it, and it will arrive today. My Maxine. So.
What is Maxine again? I forget.
That's my Mustang, Maxine. I named her Maxine when I was like 15. She's been Maxine forever. All right.
And you also won like every single drag race.
We're not going to go into that. Okay.
Drag race.
Yeah, exactly. Okay.
Drag race.
Drag race is
No.
Drew.
Drew.
Of road, and then there's 2 different cars next to each other. So
And then
Yes.
someone either turns on a
It's like
flag
Okay.
or waves a flag, and they don't.
I'm a little
Like a
older
it's like
now.
108 miles per
No,
hour.
Drew, quit.
I like the.
You're killing me, man.
I want to hear about the drag race.
Well, I'll have to tell you about the drag racing later, because here's what I want to accomplish. So there's a chance she's liable to show up between 10 and noon, and your class is only 45 minutes long. So I'd like to get through your stuff in case she shows up early. Most likely she's going to show up when we're in the middle of lab.
Who?
Maxine. So she's being carried on a transporter truck by a dude named Anthony.
Why didn't you have
Picked her up
Why
yesterday.
didn't you have Maxine right now?
Because she's been dead for 3 years. No
And
transmission,
now she's
didn't
still
function.
alive.
Because my dad fixed her. All right.
How can you fix it hard?
You have to add a new engine. You can.
Well, the engine was in okay shape, but she needed new. She went from a standard 3-speed transmission to an automatic. She has a new gearbox for steering. She has new tires, new wheels, new
How long did it
electrical,
take
new paint, new.
How long
She did
did
not
it
get air
take to fix her?
3 years, and no air conditioning, because air conditioning to convert the Mustangs is like really expensive if they didn't
Like
already have it.
1,000,
More than that.
Wait.
$10 billion.
Not 10 billion. All right, so let's look over our lesson and let's get that knocked out. So a couple of you were a little confused on how to do the last page of the lesson, and I didn't specify, so I apologize if I confused you and sent you into a tizzy or whatever, or just made you uncomfortable or unsure. So yeah, so when you looked at the last page of our lessons, that video didn't align exactly like the others did, but
Are you saying about the
yeah, you were.
Pangea?
Yeah, no, the one about geologic time, really. So, by the way, if you've gotten something returned to you and it's from lesson 2, you're going to want to clip it into your binder into lesson 2 so you don't lose it, okay?
This?
Yep, put it right back in lesson 2, behind lesson 2, wherever that is. There we go. Can you see better that way? All right. So, we're going to go over that stuff today, and I have some, like, rock samples and things that are kind of fun. All right. So anyway, that last page on geologic time, you really could kind of figure it out if you read through the whole thing, right? So it was kind of like, oh yeah, so you won Rico, and Delia got an honorable mention. Where's your Rico? Delia's Rico was cool. He had like a funky hair do, and didn't he have like curly hair? There he is. There he is. There he is. Yeah, yeah. Or is it a collar? It's a collar. It's a fluffy collar.
Wait, did I miss
And
that? Was that the same thing of rock
Show-
star?
Drew is looking for yours. There's Delia. And where's yours, Drew? So he actually did a reference to River Bottom Nightmare Band. Do you know what that reference is? Does anybody know that? Emmett Otter's Jug Band Christmas.
What?
I love cultural references. All right, so let's look over. What's your question, Jack?
I don't know if this is, but
We'll go
we
over it.
couldn't figure this out.
Don't worry about it. We're gonna go over it. All right, so if there are any blanks you didn't fill in, have your pencil ready, and let's go to the first page of our lesson 1 notes, which should be page 3 of lesson 2. So Earth's interior surface and structure. Would anybody like to volunteer to read any or all of this page to us with the answers? Go for it, Jack.
Geology is the study of planet Earth, including its composition.
Okay, hold on 1 second, Jack. Do you know where we are? Can you help her find Savannah? Oh, you're gonna go. Oh, yeah, your pages are backwards. That's all right. Switch. 1 second, Jack. So it's the page with the Earth on it, like Trev has, Jack has. Who else has? Delia has it. Flip back 1, Sky. Sky has it. Lily has it. Drew. It says 10 over 10. Honey, put that up and get your right page out. Okay, Savannah, flip back 1. You have it. 1 second, Jack. You were doing great. Flip, flip, Eleanor. Keep flipping. Almost. Keep going. You got it, Drew. It's like just past that. And flip past the right. That next page should be, that's going to be the ticket right there. Right there. Right there. Oh my gosh, they're stuck. That's it. All right. Sorry, Jack, go right ahead. Start over if you don't mind.
Geology is the study of planet Earth, including its composition. Geologists are scientists who study Earth and its process. Earth can be divided into 3 main layers: the crust, the mantle, and the core. The crust is a rocky outer layer. The mantle is beneath the crust, comprised of hot solid rock. The mantle is further divided into 3 layers: the lithosphere,
Isn't that a fun one?
Ooh,
I
the
can't even pronounce
Lithosphere. Uh-huh.
The uppermost layer of rigid is relatively cool. The blank.
That's a fun one.
It was the
That's a fun one.
Astrosphere.
It's asthenosphere.
we were me and my mom were confused if it was mesosphere or astrosphere.
Asthenosphere. That's a good one. That's like a tongue twister. Asthenosphere. Okay, good. Keep going.
So that's the
Uh-huh.
sphere, which is beneath lithosphere, is made of softer, weaker rock. The core located beneath the asthenosphere is stronger and stiffer.
Okay, so that blank.
Right
So that blank right there, Jack, after asthenosphere, that blank is mesosphere. Okay, so those 3 layers, lithosphere, asthenosphere, and mesosphere, are all part of what part? They're all part of the mantle, right? Okay, and then they're all part of the mantle, and then you had another part up here and another part up here. This part was the what? Crust? Okay, and then Jack can read that last 2 sentences at the bottom and tell us what the bottom part is there.
The blank, which I guess is the mesosphere.
That one is core.
Oh, that's core.
Yep. Okay.
It is a large sphere of metal that occupies Earth's center and consists of solid inner core and liquid outer cores.
Right. Okay. So we're gonna draw this. I'm gonna put it over on this side. Okay. So y'all might want to draw a little diagram yourselves, and if you have,
Diagram of what?
well, I'm about to do, and if you've got your colored pencils, you could always use them. So, what's the very outside layer? The very outside layer was, Drew?
Crust.
The crust. Okay, so we're gonna look at like a chunk of earth, okay? Like we've cut it, all right? So this outside is the crust, right? And what's on the crust? You know? Drew?
It's like rock and dirt and just crusty stuff, kind of.
Yeah, and water.
And water.
The oceans are floating, I mean, the water's on top of the crust of the oceans,
and
right?
it spins on top of the mantle, kind of. That's how.
Kind of, yeah. So the next part, right? This next part is the mantle, okay? And see now the mantle has 3 layers. So this is going to be our mantle, and we're gonna divide it into 3 layers. So you got 1 layer here, and then 1 layer here, and then 1 more. Okay, so this outermost layer, see the crust is very thin. I mean, I really only need to draw a line. That's about how thick it is. It's very, very thin. So this part of the mantle this is what we're calling the lithosphere, okay? Now here's something that will maybe help you remember it and maybe not. This word right here, all right? Can anybody think of a word that has that in it? Anybody ever heard of a word that has lith or litho in it?
Winter.
So how about, anybody ever heard of,
Lithium.
kind of, that one's gonna come from a different place though, different root. Okay, how about monolith? Anybody ever heard of monolith? Or,
Woolly mammoth.
not a mammoth. How about, oh, here's one. Anybody ever heard of lithotomy? You've heard of it? Excellent.
Lithology.
Oh, here's a fun one. Here's a really fun one. I love this one. Tonsillith. Mm-hmm. All right, so this lith or litho, it means stone. It's a Latin root, okay? So a monolith is like 1 stone. It's like a big giant stone. Sometimes you'll hear, you know, oh, it was a monolithic task. No, but you'll hear this big, oh my goodness, it's a monolithic task. Or sometimes you'll hear of like big sculptures being made of like a giant piece of rock, and they'll call them a monolith, okay? Like 1 big giant stone, all right? Then this one, this is the one, well, now they use this procedure for lots of stuff, but this is how they get out kidney stones. Lithotomy.
Your
Okay.
kidney is a stone.
No, but sometimes people get stones in their kidneys. So what do you think this one is? Do you recognize this word?
Oh yes.
What's that word? Tonsil. What's a tonsil? Where are your tonsils?
In your mouth.
In your mouth. Okay. Some people get,
I don't have tonsils.
you don't have tonsils,
I
yeah.
don't want to get my
Some people get tonsilliths, which are little, they're not really stones because they're made of like a pasty stuff. It's kind of gross to talk about it, but they're really common. If you ever get them, they're totally normal. Hang on, girls. So a tonsillith are little stones that you get like in the little nooks and crannies of your tonsils. If you ever see them, like if you ever look back in there, they can be like white, and they smell bad. Your tonsils are those big, if you open your throat, you see those big round things that stick out into your throat, those are tonsils. They're part of like your immune and endocrine system. All right, so that's lithosphere. All right, now here's another one. This will also maybe be easier if we just make this one the odd man out. So mezzo is another one of these, okay? And mezzo, anybody ever heard of like a mezzo soprano? That comes from the same root. That's actually M-E-Z-Z-O, but that's the Italian version of the Latin root. Mezzo means middle. Okay, so my door wiggled. So mezzo means middle. So if you look at the whole Earth, the mesosphere really is like right in the middle of everything else. Like it's the middle. All right, so we have our lithosphere, and is the lithosphere hard? Is it soft?
It's plasticky.
Well, the lithosphere isn't as plasticky. See, because it says the lithosphere is rigid and relatively cool. But what's below the lithosphere? Asthenosphere.
The,
Okay, and what's the asthenosphere like? What's the
It's-
asthenosphere like?
like isn't that the plastic one?
That's plasticky. So by plastic, we don't mean plastic. We mean somewhat flexible, right? So this part of the mantle,
It's kind of slippery.
kind of like that, yeah. So this part of the mantle is actually in motion, all right? This part of the mantle is moving. It's actually, it's really thick rock. It's not moving like water. It's very, very thick, but it does move. It probably doesn't move at a rate you could really notice with your eyes, but it does move. And when we get to continental drift in a minute, that's going to be really important to understand. And then what's this bottom one? This is mesosphere. And what's the mesosphere like?
It's very, 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 very hot.
Right?
Isn't it like 1,400 degrees or something?
I don't remember the number.
I
But
think it's
the
1,400.
mesosphere is very strong, okay? Does that help a little? So those three layers. And then what do we have in the very center?
Core.
The core. All right, now the core has, how many layers are there in the core?
Farther
There's
than the
two,
sun.
right? Okay, so there's 2 layers in the core. And what do we know about them? How are they different? There's an inner and an outer. What do you got, Julia?
There's the outer core and the inner core.
Correct. Now, which one of them is solid and which one of them is liquid?
The inner is
Wait a minute,
liquid.
Delia's answering. Wait a minute.
Oh, sorry.
Go ahead, Delia. You're not sure, do you know?
The inner is liquid, the outer is solid.
Look at the last sentence. It consists of a solid inner core and a liquid outer core. So this one is liquid. This one is solid. Okay? So there you go. So that's pretty much the Earth. The part we live on, is it very thick at all? No, it's like super thin, right? All right. So that's how we're structured. So let's look at the next page, because we're going to come back to, we're going to really want to understand about this asthenosphere moving, okay? So,
I was wondering something.
yes,
Since the Earth's core sucks everything to it,
yes,
and that's why there's gravity and whatever.
right,
It still has to go through all of the gravity still has to go through all of the rocks and stuff before it gets to you. So if you were way beneath the Earth, would it be stronger?
oh yeah, gravity gets stronger the closer and closer you get to Earth's core. All right, so rocks. All right, so now I'll read this page. Rocks are classified into 3 major groups: igneous, sedimentary, and metamorphic, based on how they form. So what kind of rocks come from magma? Who knows? Who knows? Who knows? Yes, Jackson. Igneous. Isn't that a fun word? Igneous. So igneous rock comes from magma. So magma is a mixture of molten rock and gas, which forms underground. What do you call magma when it comes up to the surface? Does anybody know? Yes, Trev. Not yet. We're almost there.
Not lava.
Lava. Okay. If it's under the surface, it's magma. If it's on top, it's lava. Same stuff.
Why?
I don't know, because somebody named it that way.
Yes.
Well, it is what it is, but it's the same stuff. Igneous rock forms when molten material, what's molten mean? Melted, right? Molten material cools and solidifies either inside or outside the Earth. So if it solidifies outside on the Earth, they call it extrusive rock. And if it solidifies inside the Earth, they call it intrusive rock. Oh, there you go. He was going to say it. All right. Now, this is interesting too. The way it cools, or the rate at which it cools, determines what kind of rock it becomes. So if you look at the picture in your examples, you've got an extrusive igneous rock that's obsidian and an intrusive igneous rock that's granite. And they look totally different, but they're formed from a lot of the same stuff. And what happens is certain minerals are going to solidify at different temperatures. So that's why some contain only one mineral and others contain lots of minerals. And if you look at that granite one, see how it's got all those little specks in it? You're probably used to rocks that look like that, right? Well, that's because all those little tiny bits of mineral all cooled before all the stuff around it cooled. So as they start to solidify and the stuff around it is still molten, and then eventually that solidifies, and that's how you get the speckledy rocks. But that one that's obsidian, that's what they call a volcanic glass. This is obsidian. And it is, I mean, it looks like glass. It's like lots and lots of silicate. There's a lot of silicate in Earth. So what I'm going to do is I'm going to pass this one around as I read. So have a look at it, pass it to your neighbor, but don't lose too much focus. This has what they are on it, because they're all numbered. Don't peel the numbers off. And then this talks about characteristics and like when they form. We did a lot of this last year in earth science, and we had one student who was like super excited about rocks, and everybody else was like, by the end of it,
Who was it?
Lily, we spent weeks on rocks. All right, so what kind of rock forms over time when sediments squeeze together? What do we call that kind of rock? That was one you had?
Yeah.
Sedimentary. All right, excellent. Good, Trav. So somebody tell me what sediment is. What's sediment? Anybody? You got it? Jack?
It's stuff that, like in rivers or
Mm-hmm.
like streams of water. It's stuff
Yeah.
that falls to the bottom
Right.
that gets collected that then solidifies.
Good, good, good. So a lot of the time it is in water. Sometimes it's not. Sometimes it's just on the surface. So sediment is basically bits and pieces of weathered rock and organic matter. What's organic mean? Do you know organic versus inorganic? That's a good one. These are science vocabulary words. Organic versus inorganic. I hate that red marker, and I need to remember not to use it. So
Why don't you like the red marker?
because it does that. Okay.
Oh, you're gonna have a lot
So
more
here's
time.
organic. And it means formed from a living thing, okay? Something that was alive or having to do with a living thing. So are you organic?
Yeah.
Absolutely. Okay. So if that's organic, what do you suppose inorganic?
Non-organic.
Right. Now this is actually a lowercase o, but I'm trying to accentuate the in. Yes, it means not organic, right? So if it's not organic, it's a mineral usually. So look around the room. Organic versus inorganic. Okay, how about this piece of the light?
That's inorganic. That's
Came from a tree.
It's
organic.
organic.
So it's organic. All right, excellent. How about the glass?
inorganic.
Inorganic, because this is silicate. All right, excellent. How about your book?
Organic.
Organic because paper is made out of like
Paper's organic, yeah, and then it definitely has some inorganic because it has the ink may be inorganic and probably maybe the cover or some other stuff on it. But you can play this organic inorganic game all day long, and sometimes you really have to think about it. But yeah, how about what do you put in your car to make it run? Gasoline. What's gasoline come from? Sometimes it's corn. Yep. And what's the other thing it comes from? Does anybody know? Petroleum, which is oil. And where's oil come from? Does anybody know?
ground.
Comes from the ground. What is it? Do you know what it is?
Whales.
It's decomposed organic matter. So it comes from leaves and yeah, basically dinosaurs. So, you know, your car's running on dinosaurs. You ever seen the,
fossil fuels?
yes, fossil fuels. Have you ever seen the Sinclair gasoline logo? Sinclair company? It's a little, it's like a little brontosaurus. It's a dinosaur. That'd be why. Actually, who liked cars as a kid? Dynaco's logo
I still watch it.
with the dinosaur on it. Dynoco. Now do you get it? Dinosaur. Yeah. Okay.
When we stopped at Dynaco at the gas station, me and all of Cam, Lucas, and me always used to climb on the dinosaur.
Oh, there we go. All right. So sedimentary rock forms over time as sediment is squeezed and cemented together. Sediment is made up of small pieces of material that come from rocks or living things. Geologists classify sedimentary rocks into three main groups based on how they form. So we have clastic. Okay, clastic is the stuff that's made from broken rock. All right. Chemical is when minerals precipitate from a solution. I'll explain that one in a second. And then organic comes from living things. So a really, really good example of an organic rock is, do you know what this is? Santa will put it in your stocking if you're bad.
Coal.
That's coal. Coal is, I mean, it would burn. Yeah. So this is organic. It's coal. All right. And here's another example of an organic rock. Do you know what this one might be? It's not limestone. Do you know? Let's think. Hang on, Drew. Before whiteboards, this was used to write on a blackboard.
chalk.
This is chalk, and chalk comes from the skeletons and the shells, primarily the shells of dead sea creatures.
Oh.
So, and like diatoms, and of course things like, mollusks and whatnot.
I still like looking for chalk rocks.
Oh, do you? Cool.
Yes, because like I always drag them on the
I'm gonna
ground to
show
see
you
if
this
they
one real
can
quick,
get
too.
chalk.
So this is a really fun one. I'm gonna show you this one real quick too, and then we're gonna do metamorphic because I'm watching our clock. This one, do you see how this one is composed of like all kinds of chunks of things? All the little chunks, you can see all the little chunks. And it's almost like, it feels almost like if you pushed on it really hard, it would break. So don't do that. But it feels almost like you could, right? So this one's called conglomerate. You ever heard of like a conglomeration, or it means like a big gathering of things or people? And that's what this is, conglomerate. It's one of my favorites because you can see all the little pieces. All right, so I'm gonna pass these. Same thing. So clastic comes from rocks. Chemical, now this is the tricky one. So chemical rocks come from when minerals precipitate from a solution. So here's a great way to think about that. Say you have a big glass of salt water, all right, and you put as much salt in as the water can hold and it no longer dissolves. That's called supersaturated solution. And then you leave it out and all the water evaporates. What will you be left with? Salt. Very good. And is it going to look like it did when you poured it in there, or is it going to look different? How will it look, Trav? Yeah? What kind of shape will it have? Do you think it'll look like those little tiny pieces you shook in there? Yeah, it'll form crystals, right? Okay, so that is a chemical rock that formed when a mineral precipitate, that's what you call it, a precipitate, when it comes out and dissolves on its own. We did a cool experiment last year. If I have time, I'll show you a photo where we did a precipitation experiment and we made these really cool blue crystals, and they were so neat under our microscope, which you can project onto my computer screen. There were all these blue like crystal shards. It was pretty neat. All right, so then metamorphic is the one that's changed by temperature and pressure, right? Okay, temperature and pressure. All right, so now we're gonna real quick do the rock cycle, all right? And I know some of you had a little trouble with the diagrams, so that's cool. We'll fix it. Remind me never to use the red again. I'll take it out. It makes me mad because it messes up my
Never use the red
Never
again.
use my red again. Oh my gosh, I know better too. Oh yuck. All right, so here's our rock cycle, all right? It's a cycle, which means you can start it anywhere. But we've got these points on it, right? Oh, let's see. Oh, I gotta draw my line. And, okay. So what's this line represent?
Or surface.
Right, so this is our surface. Everybody recognize that? Okay, what do we have up here?
Outcrop.
Outcrop. See where it says outcrop? Drew, do you see where it says that on your diagram?
Yeah.
Okay, you know what outcrop is? It's a rock coming out of the dirt, so it's exposed to the air. That's it.
Be
Outcrop.
scientific.
Very, very scientific.
Amazing.
And what's this one right here?
Get this man one.
What's this one right here?
Metamorphic.
Sediment.
What?
Sediment, you gotta read it. Drew, look at your diagram, did you? Look at your diagram, so you can follow it. And then what was down here? Metamorphic rock. Right? We're almost there. I'm just gonna, hang on. Let me see if that's my driver.
I hope. 'Cause I would.
It's not.
Aww.
It's somebody's mom. Anyway, so metamorphic rock. All right, and then right here we have extrusive, right, and intrusive. What kind of rock? Igneous. Okay, so let's just start here. What do we have right there? Magma. Okay, how do you get metamorphic rock to go from rock to magma? What process has to happen, Eleanor?
Kneading.
But now kneading? Okay, that would be a good thing to consider because it's getting smashed. How about you?
Melting.
Melting is the one we want. When something goes from a solid to a liquid.
Oh, I spelled it wrong.
Okay, melting. Totally get that. Okay, melting happens right here, right? Okay, so it goes from a rock to magma. Then what happens when it goes from a liquid to a solid? Right, cooling. So that's what's going to go right here. Right there. Now we got cooling. All right, now this is a trickier one. if you're gonna get a rock to go from, it's the guy who sprays my lawn for stuff. Hey Cole, y'all keep it down for me? You're loud. So if you wanna go from igneous rock, whether it's extrusive or intrusive, to rock that's entirely outside and it's being exposed to rain and wind, it has to undergo a process called uplift. And that doesn't mean you uplift it and make it feel better. It means it gets lifted up, right?
It's okay for a little rock.
Pour the rock, it'll be all right. All right. So then, how do we turn rock into sediment? Water's one way. Yep. Weathering is that covers all of them. Okay, so weathering is the process. It can be water, it can be wind, it can be all kinds of things. Weathering, okay? This is the process of breaking it down. All right? So rocks can be weathered chemically or mechanically. Chemically would mean like maybe the rain is kind of acidic and it causes the rock to break down. Or it could be, or for example, like limestone caves underground, just water oozing down into the ground can dissolve the limestone because it's a little bit acidic, the water is, and it dissolves the limestone, and then you get these cool limestone caves, and then sooner or later the limestone cave collapses and you get a big sinkhole. So you got sediment, all right, and then what has to happen to the sediment for it to become a, oh, we didn't put our sedimentary rock here, we missed it. That one's right, jeez, sedimentary rock, it's right in here, right? Sedimentary rock. Okay, so what has to happen to it in order for sediment to become sedimentary rock? Do we know? So it's this process. We're going to just put this word in. This is a big one. There's a couple of them that have in that. Compaction. What's compaction mean?
Like push together and squeeze.
Yep. Squash. Squish together. And then this last thing here that has to happen, you know?
Heat and pressure.
Heat and pressure. Very good. Heat and pressure. And then it changes into metamorphic rock. All right, now this is the part, this is where it's going to be really important to understand the business about the asthenosphere, okay? So, everybody have all that? All right, so plate tectonics. You watched the video on plate tectonics, right? Watched all the continents shift around?
Yeah.
Okay, so which layer of the earth, which layer of the mantle is moving? Remember?
The
Magma.
The one when nobody wants to say, the asthenosphere, right? Okay, so you got your crust and your lithosphere, and then you have the asthenosphere, all right? Plate tectonics is the idea that plates, so it says under plate tectonics is the theory that pieces or plates of the lithosphere move about slowly on the asthenosphere. So the theory of plate tectonics explains the mechanism for continental drift, which is the theory that the continents we know today were once joined in a single supercontinent and broke into pieces that moved apart. So Pangea, which means all land, was the name we gave to that continent. It's actually been mashed together in all kinds of various ways over time. So anybody been up to the mountains up here? Ever? You go up to the mountains up here? What mountain range is that? Smokies is part of it, but what do we call the whole chain, do you know?
Appalachian.
Appalachian. Okay, Appalachian or Appalachian, depending on where you're from. Okay, so that entire mountain range is from a point in the past when what we know today as Europe slammed into what we know as the eastern coast of the United States today. And it squashed it. And when it squashed it, it made mountains. Oh, I'm going to pass these metamorphic rocks. I know, so rich. So I forgot to pass the metamorphic.
cause a revolution.
Sorry, babe. Here you go. So hang on, Drew. So, I mean, think about it. If you had a piece of paper and you squished both ends, or a towel on a table, it would go boom, 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 right in the middle, right? And then over time, you had icebergs that came down and floated through there, and that smoothed them all out. And they're old, okay? But, you with me, Eleanor? You good? You with me? Okay, good. So, the Rocky Mountains, anybody ever seen the Rocky Mountains? You know what they look like? They are jagged and pointy, and they are all sticking up like this, okay? They don't look like our Appalachian Mountains. They're not covered with trees. They're not smooth and rolling. And that's because they are from a more recent collision on the West Coast, okay? Because there's a plate over there, and it's coming together with this plate, all right? So if you've got this asthenosphere and it's constantly moving slowly, and then you have plates of the lithosphere that the crust is attached to, and they're floating on it, they're always kind of moving. Now, okay, what's making the whole thing move? This is the tricky part to understand. It's called convection heat. All right, so here's a great example. We did a lab last year that really showed it. We took a big pot and we put tomato soup in it. And we put a bunch of little Ritz crackers on top, and then we turned on the heat. What do you think would happen to the crackers when we turned on the heat? Does anybody have a guess? Do you have a guess? A hypothesis?
I'm guessing that they dissolve.
That's a good guess. Eventually they did. Do you have a guess?
They
They move apart. Exactly. So what you have is convection heat. And convection heat looks kind of like, and this yucky thing, but it looks kind of like this. It's cyclical. So you get this temperature, and as the fluid, whatever the fluid is, in this case, it's going to be rock, molten rock. But in our case, for our lab, it was tomato soup. As it gets warm, it rises towards the surface, right? It's getting hotter and hotter. And then when it gets up here, it's going to get cooler because it's getting exposed to cooler temperatures. So then what's it do? It comes back down and it gets hotter and it rolls, okay? So that's why the crackers would move. So on the asthenosphere, we have this rolling. And the rolling is because of the heat, but here's also something to know, because this is interesting too. The other thing that plays a role in the direction of the roll is the fact that what we have is molten rock, and some of that rock is mineral iron, and iron is magnetic, and Earth's poles are magnetic. So Earth's poles are pulling the molten rock in a certain direction, and the heat is pulling in a certain direction, and that's what causes the directional movement of continental plates. It's really cool. It's like if you watch the video, right, it goes like, oh, over time it kind of moves everywhere, right? It doesn't just bounce back and forth like this. It floats everywhere. So I'm gonna read this last page to you, and then I think we'll have time to go over the homework, and if we do, I can give it back. So let's see. All right. So geologic time scale is based on relative ages of rock layers and the use of radioactive dating to find absolute age of rock. So relative age is when scientists find a rock and it's in layers, and they look at it and they look at fossils that are found near it, and they take that information they know and they make an educated guess as to the age of the rock based on what is a hypothesis, based on what is below it and what is above it, okay? Absolute age is when they take radiocarbon dating and they look at certain molecules and certain atoms within the rock, and they see how much it's deteriorated, and they can get an exact age. And that science is really specific, like they can get very specific. So what's the longest period of time? Can anybody tell me? This is the first blank. Jackson? An eon. Okay, eon's the longest period of time. And what are eons made of?
Eras.
Eras. Good. And so eras last up to hundreds. Hang on, that's my guy. GPS says 11 a.m. with traffic probably between 11 and 11:30. Awesome.
See it?
Yep.
Yes.
All right. So eras are made up of. Anybody know what eras are made up of?
Period.
Periods. Good. And periods are made up of. Anybody? Epochs. Okay, that's a fun one. Epochs too. All right, so you've got eons, and these are like millions and millions and, millions and millions of years. And then you got eras, and those are hundreds of millions of years. So you know how big eon is, right? Huge. And then you've got eras, eons are tens of millions of years. Eras are tens of millions of years. Eras are hundreds of millions of years. I cannot read because I'm very excited that this man just texted me. And so periods are made up of epochs. Periods are tens of millions of years, and epochs are hundreds of thousands of years. So you can take today, and you ever seen a nesting doll? It's like a little doll, and then you put it inside of another doll. We have them at Christmas sometimes, right? Keep going until they get bigger and bigger. So you can take today, that can be your tiniest doll, and you can put it in an epoch, and you can put it in a period and an era and an eon. And you can do that with any day that has ever occurred, okay? You can put it in that category. So scientists can determine the relative age of a rock by comparing it to the rock below and above. So what law do scientists use for that? Anybody know? Anybody know? Yes.
Superposition?
Superposition. That is exactly what it sounds like. It's a compound word. Super meaning above, position meaning position. So it's the idea that the oldest layers are at the bottom. So think about it. If every day you took all the trash from your house and you dumped it into a bin, okay? You did it every day, every day, every day, and then you're like, oh my gosh, today's Friday, and on Monday I accidentally threw away my tickets to the Georgia Tech game or whatever. Are you gonna look on top for them if it's Friday and you lost them on Monday? No, where are you gonna look?
At the very bottom.
At the bottom, right? Because your newest layers are on top. That's superposition. It's that easy to understand.
I
So
could just be like a raccoon.
yeah, the law of superposition states that the oldest rocks are on the bottom. Now this does change if there has been movement in the crust, uplift in the crust. There are some places where there's been uplift in the crust and it causes the rock layers that are all situated like this to shift or to fold. And you can see that in places, and it's really cool because usually there's colors and they move. All right. And then let's see. Geologists use a law of superposition to determine the relative age of sedimentary rocks from the sequence of rock layers and fossils found within each layer. Geologists use radioactive dating to determine the absolute age, and that's the time passed since a rock was formed. So we have 2 minutes. So here's what I'm going to do. I'm going to grab your homework for you, and we're going to go over it, okay? And that way, that's one less thing you have to wait for, because we got 2 minutes, so we'll go ahead and grade it. That's cool. I like to do that on stage. It's like a treat for everybody. All right. Lily, this one's yours. Drew, this one's yours. Okay, Delia, this one's yours. Jackson, whoops, you have 2. Jackson and Jack. Did you both write Jackson, or are they both yours?
They're both his because I don't write Jack.
Oh, this is 3. This is the one you owed me. Got it? Okay, sorry. Eleanor, yours is here. Trav, yours is here. Got it?
It said Rockstar.
And Jack, yours is here.
Your mom.
Hang on, wait a minute. This one you owed me. Okay, everybody, and you can do yours right now while we're doing it. Do you see where it is? You don't have it with you at all? Okay, so write them down. Write the answers down somewhere on the side or something so that you can just write them when you get home. Yes?
We all drew different pictures.
It's fine.
She drew
fine.
Rockstar. And
Don't worry about it. Savannah, do you have yours with you? Did I hand it back to you? Or do you have it? No, flip back one more.
I'm supposed to do.
Not that one. Hang on.
Rigo.
Right. It was right here. It might be with the labs. I'll look real fast. And then we're going to run over it. Get you started on meeting this.
So
Yes.
what are we supposed to do?
Okay.
What
All right,
she found it.
She found it.
Got it? Okay.
So now what are we supposed to do?
So we're going to look over the answers together. So you're going to grade your own paper. Okay? All right. So
Okay.
would anybody like to tell me the answer to number 1? Delia?
Mantle.
Mantle. Very good. If you don't have mantle, change it to mantle. So which of the Earth's 3 main layers is the thickest? Mantle. All right. Give an example of an intrusive igneous rock. Who has examples? Drew?
Clay. Chalk. Obsidian. And rock.
Well, chalk's a sedimentary.
Oh,
But yeah, okay. Go ahead, Jack.
Diorite.
Yep. Anybody else have one? Trev?
Granite.
Granite?
I'm gonna say granite.
Granite. Yeah, it's probably the most common one. All right. Blank and blank change igneous rock into sedimentary rock.
Heat and pressure.
Heat and pressure, very good. So the one thing we didn't draw here is that there can be another arrow that goes like this. It doesn't have to be sedimentary rock that becomes metamorphic rock. This rock can do it too. It doesn't have to break down, right? It can go straight from igneous. Oh, I wrote on myself. All right. Explain how plate tectonics is a mechanism for continental drift. So this is what we just went over. Do you have it, Trev? Do you want to give it a shot?
Plates are top with the Earth's crust and the convection.
Yes, perfect. They move with convection. You got it. That was perfect. So it was basically what we just discussed about convection heat and the mantle moving and that moving things around. Perfect. All right, now this is a good one. Research. What type of rock is Georgia's Tate House constructed from? And Is it igneous, sedimentary, or metamorphic? So who wants to tell me? You tell me what it's constructed from.
Made of pink and white marble.
Perfect. Yep, they call it like Georgia pink marble. Okay. Now, is it igneous, sedimentary, or metamorphic? Do you know? Okay. And how about something that's constructed? Yes.
Like
What art
museum
museum?
also?
Yep.
Well, you put Jocelyn Art,
There you
National
go.
Gallery, and Knoxville.
There you go. Yeah, I think probably the best known one's the Jocelyn one. Did anybody see pictures when they were looking it up? It's pretty cool. Yeah. All right. Excellent. So you guys just did your homework. That's done. Now you don't have to mess with it anymore. Isn't that kind of nice?
What do I do when check off?
You can check it off, and I'll check it into your grade books. So it's time for us to start lab. So I'm going to kill this video. Bye. And then
Let's see it. Are you gonna